Okay, this is a video for 8.5a, transformations of inverse functions. So, on the left of this worksheet, I've drawn the general equation for a square root function as well as a cube root function. So we want to take a look at some examples today, look at the equations we're given, compare them to our general equation, and find information such as a starting point and be able to sketch the graph and things like that. So let's start with example 1. Example 1 is a square root function, so we'll use the black equation on the left. We want to find the starting point. The starting point for a square root function is going to be hk, h comma k. You can see in the equation in example 1 that h is 3, but because it says x plus 3, plus is the opposite of the minus over here in our square root equation, and so that means that our starting point is going to have an x value of negative 3. And there is no k, so that means our k is 0. So our starting point is going to be at negative 3, 0. Once we find that, we can sketch this graph roughly as something like that. Alright, now let's take a look at number 5. We want to do the same thing, but as you can see in number 5, this is a cube root function. The point of inflection in a cube root function is also hk. You can see that since it says x minus 5, that h is going to be 5, and there is no k, so k is 0. Our point of inflection is at 5, 0. 5, 0 is right here. And so we can sketch this graph as roughly looking something like that. Alright, now let's compare it to a couple other things. We want to describe in 9 through 12 how the graphs differ from y equals the square root of x, figure out the starting point, and identify the domain and range. So we're going to work with the square root function. And this differs from y equals the square root of x because our starting point is different. Our starting point is going to be negative 10, 6. So that means we've shifted left 10, and we've shifted up 6. And then our domain is going to start at an x value of negative 10, and then it continues on forever to the right. Oop, not that button. Continues on forever to the right, so that's infinity. Negative 10 to infinity. And we also see that our range, which is our y values, start at 6. So our range starts at 6, and then that will continue to infinity as well. Alright, let's do a flip to the back side. Describe how the following graphs differ from the cube root of x. So now we want to find the point of inflection, the domain and range, and talk about the shifts in this one as well. Let's take a look at 13. Just as a reminder, the cube root function is y equals a times the cube root of x minus h plus k. So, let's figure out the point of inflection first. The point of inflection is h comma k. There is no h, so that's a 0, and we can see that k is 7. Take a look at this negative as well. A negative a value means that's a reflection over the x-axis. So we reflect first, and then we don't go left or right at all because h is 0, but we shift up 7. Alright, and now let's identify the domain and range. On the cube root function, the domain is going to be all reals. It'll extend in the x direction forever, left and right, and it will also extend up and down forever. So the range is going to be all reals as well. Final one. Let's take a look at this graph on 17, and we want to create an equation. First thing to notice that because this does not extend in both directions forever, this is a square root graph. Not a cube root, but a square root. So our equation is going to take the form of y equals a times the square root of x minus h plus k. Now, in this example, a is going to be 1, so our equation is going to start with y equals, we just don't have to put a, it's just 1, x minus, and we can see that this graph has been shifted 2 units right, so x minus 2, and it's also been shifted 1 unit up, so plus 1. And that is the equation of the graph.